My investigation is about adopting a nuclear power plant to Sri Lanka, and I am Tarun Veeraratne, a fourth year mechanical engineering undergraduate. So first let me ask you a question. What would you picture when you hear the word nuclear? And do these pictures describe what's on your mind? So believe it or not, this is one of the biggest barriers that is stopping Sri Lanka from adopting a nuclear energy power plant. That's because the fear in the people's mind can be used by the politicians to stop us going forward. Therefore, the main aim of this study is to raise the awareness of this matter among the academics and as well as the public. So, what is basically happening in a nuclear power plant is converting atomic energy to or the energy embedded in atoms to electrical energy. Even though 30 countries have already have 440 power plants, Sri Lanka is still in the pre-feasibility stage. So if you take a look at the energy generation in Sri Lanka in 2019, you could see almost half of the energy is generated using thermal power plants. I think now Sri Lanka is in between the options, a coal power plant or a nuclear power plant. But however, the initiation year would be about 2030. So the method is quite simple. First, we have to identify the key factors that has to be considered to conduct the pre-feasibility study, and then decide on the areas to cover. For some areas, the calculations has to be done to study the feasibility and compare them with the rival technology, that means the coal power. And finally, conclusion is done by giving some recommendations. So the aim of this study is to check the feasibility in the following areas of interest. Other than that, recommendations are given in Sri Lanka is to adopt a nuclear technology power plant. And the following key factors needed to be considered when evaluating the areas of interest, but here we take only 9 of them for our study, and since others are beyond our scope. So to access the financial viability, we have taken these key parameters to calculate the profit during the lifespan of the plant. We will see how these parameters come into play in the next slides. So first we need to know what is the annual unit generation cost or the cost of 1 unit of electricity. For that, we have to get the sum of fuel operation, maintenance costs, and as well as the decommissioning and carbon charges. After that, we should divide the total by the annual electricity generation. So this is a comparison of capabilities and the costs between coal power plant and a nuclear power plant. Here you can clearly see the capital and the fixed costs are higher when using nuclear technology, but the capacity is also higher than a coal power plant. And in order to calculate the profit, we use the shown formula, and it is pretty straightforward. We only have to get the difference between the selling value and the cost value during the whole lifespan of the plant. And again, if we are to compare with the coal energy, it is crystal clear that the nuclear power is 100 times profitable in the long run, since the average lifespan is about 60 years. So if we move on to the environmental impact, the biggest concern is nuclear waste management. The main substance is wastewater, and there are several methods to dispose them. But in Sri Lanka, we have this resource, a special resource, residual mountains. This option will not only minimize the area of disposing, that means it saves the area which is useful, but also minimize the risks of mixing the groundwater with the contaminated water. So so this is a picture of a residual mountain which has been used to dispose nuclear contaminated water. So when considering the technological features, VVER 1000 and AP 1000 models are the most advanced one, and both of them are pressurized water reactors. And most importantly, they are the most suitable ones in Sri Lankan context, considering the environmental condition and as well as the financial conditions. And when choosing a site, which is one of the most important ones, the following factors have to be taken into account. And these factors directly connect with the capital cost and the operation, maintenance, all the costs, and as well as the safety. So at the left figure, you see a map of Sri Lanka which shows the areas which are more vulnerable to floods, and they are in the dark color. And in the right side, you see the areas which are more vulnerable to landslide, and those are in dark color. And in the next slide, you see the history of cyclones in Sri Lanka. The darker area is more vulnerable here also. So we cannot afford to have these risks in a nuclear power plant site, because they can lead to huge losses in finance or human resources. And when talking about human resources, the less populated areas are the better option, since it would reduce the damage in a nuclear hazardous situation. So using above data, we have recognized that the northwest area and the southeast area would be the most optimum locations, but southeast areas are somewhat vulnerable to tsunami disaster when talking about the history. Therefore, the most suitable one is the coastal area from Kilnochi to Puttalam. So and one of the major concerns of the public about the nuclear technology is safety. Nuclear safety can be enhanced using inbuilt safety features of the reactors and improving hazardous responsiveness. And also nuclear waste management should given a special attention. In terms of energy security, an organization which is responsible to has to be launched in Sri Lanka for nuclear safety and security and the radiation protection. It is recommended to reinforce the law and implement custom borders controls and develop human resources, and it would benefit in the long run. So if we so it is clear to us that adopting a nuclear power plant is economically beneficial for a country like Sri Lanka in the long run, but the capital investment is intolerable for the economy. So if Sri Lankan government decided to go for it, the optimal location would be the coastal area from Kilnochi to Puttalam. And in this research work, when talking particularly about this research work, the safety procedures in the power plant itself has not been discussed thoroughly, and also choosing of a reactor type is not discussed in depth. Therefore, it is better if all the aspects were discussed in the future work. And taking all the key factors into consideration is another thing, rather than only using 9 key factors as I have mentioned earlier. And lastly, it is better to suggest a procedure to raise the awareness of nuclear power among the general public and as well as the academics. So this is what I have done for the research work. And thank you for listening.